Hi everybody, today we're looking at arithmetic sequences, and they are generally speaking linear patterns that have a constant difference, as linear patterns do. And when we have these linear patterns, they're either called arithmetic sequences, arithmetic progressions, or APs. So let's look at a few quick examples. Set this up nicely. So 2, 3, 5, 7, 9 is an AP. 1, 5, 9, 13, 17 is an AP. In this case, it's going up by, or is it an AP? No, it's not. Why is it not? Because it's not going up by a constant increase. Let's fix that. 1, 3, 5, 7, 9, each time going up by 2. 1, 5, 9, 13, 17, going up by 4, going up by 4, going up by 4, going up by 4. Has a constant difference, is an AP. Going down by 2, going down by 2, going down by 2, going down by 2 has a constant difference of negative 2. Now let's just have a look at this case here, 2, 4, 6, 8, 10. Here we go again. Now we have an arithmetic progression. The first term is 2, and the common difference is also 2. It's going up by 2 each time. So with all of these cases, they have a specific form. They have a first or an initial value, and then we add on the difference. And for this second term, we've added the difference on once, then we've added it on twice, then we've added it on 3 times, then we've added it on 4 times. And we can generalize this to A plus D, A plus 2D, A plus 3D. In the case of this, if the difference was 2 and the initial value was 2, 2 plus 2 is 4. There it is there. 2 plus 4 is 6. There it is there. 2 plus 6 is 8. There it is there. And so on and so forth. Now we can generalize that into the following recursive formula. Well, actually no we can't. We can state the generalized recursive formula for an AP as being the next term is equal to the current term plus the difference. So this term, let me get my marker back. This term here is equal to this term plus the difference of 2. This term is equal to this term plus the difference of 2, so on and so forth. Or we could define it as the current term is equal to the previous term plus the difference, where the first term is A. So the current term is equal to the previous term plus 2. The current term is equal to the previous term plus 2. So importantly, if a sequence does not have a common difference, it's not an AP. So 2, 4, 8, 16, 32, it's not going up by 2 each time, it's not an AP. In fact, we'll look at this sequence later and see exactly what this is. So let's do some examples. Are these APs, and what is their recursive definition? It has a common difference. It is 3. It's really easy to do the AP. The first term is 4. There it is there. The next term is equal to the previous term. The next term is equal to the previous term plus 3. The next term is equal to the previous term plus 3. Or the next term is equal to the current term plus 3. However you're thinking about it. It doesn't really matter as long as it's clear in your head. Next one. Each time it's going down by 3. The first term is 38. And it's going down by 3. The next term is equal to the current term, take 3. Next one. Oh dear. 2, 4, 8, 16. This time it is not going up by a common difference. It is not an AP, but we can still do a recursive formula. It starts at 3, and if we look at the next one, it's doubling it minus 1, doubling it minus 1, doubling it minus 1. So the next term is equal to 2 times the current term minus 1. There we go. Easy enough. So APs create linear patterns that can also be represented in the form y equals mx plus c, as we've done before, where y is the term required and x is the position in the sequence. And when we look at series, we'll see something similar to this. But for now, just know that it can exist. Sequence mode in a calculator is a good way to find the nth term. So if we have the sequence 2, 4, 6, 8, 10, given 2 as the first term, t1, find the 251st term. Well, I'll pop out of full screen mode and I'll get my calculator up. Here it comes. And I think we might do this in sequence mode because it takes forever to do this type of problem in spreadsheet mode. So let's see, what would the formula be? Its first term is 2 and it's going up by 2. And we want the first term, so let's start it in terms of the first term. And the first term is 2. And we're wanting it to be the previous term plus 2. There we go. Tick that, and let's have a look at the first 5 terms to make sure that we've got the formula correct. We want to start at 1, and we want to go to 5. Okay. Go OK. Press the table button, and we get 2, 4, 8, 6, 10, 2, 4, 6, 8, 10, which is what we're looking for. Now the trick here is we want to find the 250 first term, so let's find 250 to 255. And hit the table button. And the 250 first term is 502, as written over here. Marvelous. Okay, so we've done that one. And that pretty much precludes, well not precludes, pretty much concludes the AP's little video. So thank you everyone, and I'll see you in the next one.